Okay, two very special functions, the common log and the natural log. Now these are two buttons that we have on our calculator, the log button and the ln button. You may recall the ln button from when we had e to the x power was up above that ln button in the previous section. So these are defined to be whenever you see a log and it doesn't have a base indicated, that is automatically log base 10, and we refer to that as the common log. All right, the other one, the natural log, is by definition log base e. All right, so we can always rewrite these with the bases so we can see them if that helps out as we go through problems. But know that natural log and e are kind of intertwined, and then common log is automatically log base 10. So to get through these next problems, we're going to rely on these properties that exponential functions and logarithmic functions are inverses of one another. So if you compose them together, if you plug an exponential function inside a logarithmic function, as long as the bases line up, like log base a of a to a power, they have the same base, we're going to get this very nice cancellation, and you're going to be left with whatever your exponent is. Now the opposite is true also. If we have a logarithmic function up in the exponent, right, so it's inside of an exponential function, if they have the same bases, a raised to a power and log base a, nice cancellation happens here and we're left with x, whatever was inside of the logarithm. So let's use that, try to line up our bases and work a few of these problems. Okay, so we want to first evaluate log of 1000. All right, now it is a button on our calculator we're allowed to use, but let's use those inverse function property on this one instead. Now that's automatically log base 10 of 1000. And if we can possibly rewrite that 1000 so it's a base of 10, we get that nice canceling out. So we are allowed to rewrite 1000, that's 10 to the third power. Now it looks like that inverse function property can be utilized, and this will just be equal to 3. All right, it's basically the same thing we had going on over here, log base 10. And then 10 raised to the third power, so our answer is just going to be whatever that exponent was, the 3. All right, let's give it a shot with this natural log of e to the fifth power. So in this case, remember natural log means log base e, by definition, of e to the fifth power. Same base on both pieces, so they're inverses, so you can get to cancel them out. All right, let's give it a shot with log base 2 of 16. A little bit different here. I'm not going to be able to rewrite that base. It has to remain a 2, but we can focus on the 16 on the inside and say to ourselves, well, can I rewrite 16 as 2 to a power? Well, it goes 2 to the first is 2. 2 squared, that's 2 copies of 2 multiplied together is 4. Then 8, then 16. So I think by my count that was 2 to the fourth power is the same thing as 16. Which will do some nice simplifying down. Now that we've lined up the bases to be the same, you're going to be left with 4 as our solution. Let's run through these next ones real quickly. This one's kind of aligned in the opposite order, where we have e as the base, and then that's really raised to the natural log of e. The natural log is log base e of the square root of 5. But that part's up in the exponent, so you get that nice canceling out, just in the other order this time around. Now let's see some trickier ones where we have log base 3 of 1 over 243. So to get going on this, we can't really change the log base 3. But let's work on rewriting 243 as 3 to a power. I'm not going to try to do all the steps all at once. I'm going to take my time and get going on this. So I'd like first just to go with 243. We can test different powers of 3 by doing 3 to the first power in our calculator, 3 to the second, and so on as we work through these. But I found that 3 to the fifth power is the same thing as 243. All right, from here, we can't just cancel out here and get 5, because remember our property said it has to be log, and in our case base 3, and then 3 raised to a power. So we have to kind of go back to our properties of exponents and want to move that up to the numerator. So we're going to have to make that a negative 5 3 to the negative fifth is equivalent to 1 over 3 to the positive fifth. And now we're going to get that nice canceling out using the inverse function properties. Okay, we can do something pretty similar here with our natural log of 1 over e to the fifth power. I could rewrite that natural log, but instead I'm just going to leave it as a natural log this time. We've already seen that that means log base e. And again, we can take the e to the fifth power, move it up to the numerator, and make it a negative exponent. So our solution here is going to be negative 5. All right, this one fools a lot of students. All right, but it does go back to some of our exponent rules. All right, remember, if we have log base 5, our goal would be rewrite what's on the inside as 5 to a power. But 5 to what power equals 1? Well, anything raised to the 0 power is always equal to 1, so we can rewrite 1 as 5 to the 0 power. From here, same bases, we line those up very nicely. Our end result is going to be 0, completely simplified down. All right, hope this helps out. I know it went pretty quickly, but good luck.